All right, so these are your electron dot diagrams, or we call those Lewis dot diagram notes. Let's go. All right. So if you remember thinking back to the atomic theories, there were several, and the second to last one was Niels Bohr's model of the atom. It basically said that around the atom there were different energy levels, and in those energy levels were a certain number of electrons. We no longer hold that to be true. We know that's not entirely the picture. We now know that there are clouds that we can find electrons in these different probability states. They're not on like a ring around the nucleus, but in terms of drawing where valence electrons go, the Bohr model is the easiest way to think about it. So for the purpose of this, we're going to use this model. So valence electrons are the number of electrons in the outermost energy level. So if we think back to the electron configurations that we just did, the energy levels are the big numbers, or the n's at the beginning, that we see over on the side that describe each period of the periodic table. So they go from 1 to 7. So these are the electrons that are in the outermost energy level. So if I'm talking about something that has a whole electron configuration and it ends with 4p3, then I'm talking about the electrons in that fourth energy level. So because of that, there can be no more than 8 valence electrons. The reason, I'll get to that in a minute. So the electron dot diagrams, or the Lewis dot diagrams, they show where these valence electrons are around an atom. Valence electrons are only located in the outer level s and p orbitals. So if you think about the electron configurations that we just did, it would only be the S and the P because the D is always one energy level below, right? So if we're talking about 4S, 4P, then there would be a 3D. So it's because it's that 3, we're no longer talking about valence because it's not in the outermost energy level. The same goes for the F block as well. The valence electrons are shown in the outer energy level of a shell diagram. So if we were to draw it, they would be on the very outside. So just a reminder where the blocks are, these should be on your periodic table. So the shell diagram is this visual representation of the Bohr model, where we have energy level 1, energy level 2, energy level 3, and each of these circles that have a negative in them represent an electron, right? They show the nucleus just with 13p and 14n instead of individually drawing the circles for protons and neutrons. So the outermost level is where we call where our valence electrons are found, and we actually call that the valence shell because it's the outside, the shell of the atom, so to speak. So in order to draw an electron dot diagram or a Lewis dot diagram, it's really simple. So you just write the chemical symbol, which you get from the periodic table, right? You see these here. You place one dot around the chemical symbol for each valence electron. So helium only has 2 valence electrons. These are all of our noble gases. So the rest of them have 8, and you can see that because there are 8 dots around it. And typically what we do is we say, you kind of draw an imaginary box, right? Don't draw a real box, imaginary box around the symbol. And on each side, you put 2 electrons. Okay, so like helium only has 2, so you can see I only put them on the same side. And so you kind of fill them in. So if you had something that had 3, you would write, okay, 1, 2, 3, and that would be it. Okay. All inner level electrons in the nucleus are symbolized by the chemical symbol. So we think, okay, krypton has a lot more than 8 electrons. Well, we just assume, and we know that based on the fact that we wrote Kr. Right now, we are just trying to show valence electrons. So if we practiced drawing the Lewis structure for silicon, we would look at our periodic table and say, okay, the outermost energy level for silicon is the third one. So silicon has 3 S2, 3p2. So it has a total of 4 valence electrons. So I would draw one here, one here, one here, and one here for a total of 4. Now I'm going to do calcium. So if I look and find calcium, its outermost electrons, the highest energy level it gets up to is actually 4. And so in this case, it would be 4s2. So I would just draw 1, 2 to represent that it had 2 valence electrons. All right. So this is fairly simple. You'll never have more than 8, and you'll never have less than 1. Okay. So in your notes, I want you to practice. So you might need to grab a periodic table for this. Practice drawing the Lewis dot diagrams for elements with the atomic numbers 37 through 54. So that's all of them. So it's an entire period. For each diagram, write which energy levels these electrons reside in. When you're done, come and show me your notes so that I can give you a note check grade. All right, if you have any questions, also feel free to come find me and ask.